Matrices, the basic operations, addition and multiplication. First, let has a brief history of matrices. So who introduced the term matrix? The term matrix was introduced by the 19th century English mathematician James Sylvester, but it was his friend the mathematician Arthur Cayley who developed the algebraic aspect of matrices in two papers in the 1850s. Who was the first to derive the rule of multiplying matrices? So the first to derive the rule of multiplying matrices is Jacques Philippe Marie Binet, who seemed to recognize as the first to derive the rule for multiplying matrices in 1812 rather. So the addition of matrices. It is denote the sum of two matrices A and B of the same dimensions by C is equals to A plus B. So the sum is defined by adding in entries with the same indices. For example, how can we find the sum of the two matrices A and B? So in adding the two matrices, all we have to do is to add the entries with the same indices. So this 1 plus 5 is equals to 6, 2 plus 6 is equals to 8, then 3 plus 7 is equals to 10, and 4 plus 8 is equals to 12. So that is the result. Next is the scalar multiplication. So in multiplying a scalar multiplication, all we have to do is to multiply the real number and a matrix of each element is multiplied by that number. For example, a real number and a matrix. So how can we divide it? How can we multiply it? All we have to do is to distribute this real number in each of the entries of a matrix. Like this. 5 times 1 rather is equals to 5. 5 times 2 is equals to 10. 5 times 3 is equals to 15. And 5 times negative 1 is equals to negative 5. 5 times negative 2 is equals to negative 10. And 5 times negative 3 is equals to negative 15. So that is the result. Next is the multiplication of a row vector by a column vector. So multiplication is only possible if the row vector and the column vector have the same number of elements. To multiply the row by the column corresponding elements are multiplied then added to the result. So for example, a row vector with the entries of 1, 2, 3 and a column vector 4 with the entries of 4, 5, 6. So we can multiply this by making this into by supposing this as a vertical. So we will have 1, 2, 3 times 4, 5, 6. Then multiply 4 times 1 is equals to 4, 2 times 5 is equals to 10, and 3 times 6 is equals to 18. Then find the sum of these three. 4 plus 10 is equals to 14 plus 18 is equals to 22. So the result of this multiply for this is 22. Next is the product of a row vector and a matrix. So when the number of elements in row vector is the same as the rows of rows in the second matrix, then this matrix multiply can be performed. For example, in multiplying the product of a row vector and a matrix, all we have to do is to first step is to multiply the row of this and this column. It's like that. For example, the 1 times 2 is equals to 2. Then 2 times 3 is equals to 6 plus 6. Then 3 times 4 is equals to 12. Be like that. Then is to multiply this again and this for the second row. So 1 times 1 is equals to 1 plus 3 times 2 is equals to 6 plus 3 times 1 is equals to 3. Then this. Next is this is the third column. 3 times 1 is equals to 3 plus 2 times 2 is equals to 4 plus 2 times 3 is equals to 6. Then simplify. 2 plus 6 plus 12 is equals to, then simplify 2 plus 6 plus 12 is equals to 20. Then 1 plus 6 plus 3 is equals to 10. And 3 plus 4 plus 6 is equals to 13. So that is the result of if we multiply the row vector and a matrix. So another example, a row vector and a matrix. So the answer is you can't. Why? It's because this row is 1 by 3 and this matrix is 2 by 3. And why we can't multiply this given? It's because the column of the first given is not the same to the row of the second given, so it is not defined. Next, the matrix multiplication, the general case. So same as the other given, in multiplying the matrix, a 2 matrix is the column the column of the first matrix should be the same in the row of the second, the number of the rows in the second matrix. So for example, the matrix A and B. So in multiplying these matrices, we have to do, so we can multiply this because the number of rows of the first matrix I know. The number of columns of the first matrix is the same as the number of rows in the second matrix. So this 2 by 3 and a 3 by 2. So the inner is the same. So we can multiply it. The result of these matrices should be like this. It's a 2 by 2 matrix. Next is the first step in multiplying a two matrices is we'll find the position of So for example, we will first find this position. So since it is in the first row and it is in the first column rather, so we will multiply each term. So 1 times 3 is equals to 3, and 1 times 3 is equals to 3, and 5 times 5 is equals to 25. So add each term, so we will have 31. So this is 31. Next is to find this. So since it is in the first column and it is in the first row rather, and it is in the second column, same as in the procedure in finding this, multiply each term. 6 times 1 is equals to 6, and 4 times 3 is equals to 12. 2 times 5 is equals to 10. So add all of this. 6 plus 12 is equals to 18, plus 10 is equals to 28. Next is this. We will find this part. So 2. So since it is in the second row and it is in the first column, we will multiply each term. So 2 times 3 is equals to 6, 4 times 1 is equals to 4, and 6 times 5 is equals to 30. Is equals to 40. Next is we'll find the last and finally is 5. I know, since it is in the second row, the position of this is in the second row and it is in the second column. Then multiply 12, 16, and 12. 12. So 12 plus 12 is equals to 24, plus 16 is equals to 40. So that is the result. So that's all. Hope you understand my report. Thank you.